Welcome to lesson 12.5, the Pythagorean Theorem. So a few things to keep in mind with the Pythagorean Theorem are number one, that it only works with right triangles. So if we have an acute or an obtuse triangle, the Pythagorean Theorem will not work. So it only works to find a missing side length or to find area related to right triangles. But in this case, again, we're only looking at using it to find missing side lengths. And in this case, it only works with right triangles. Then in the Pythagorean theorem, which is written as a squared plus b squared equals c squared, a and b are always the legs of the right triangle. So the legs of a right triangle are the two sides that meet at 90 degrees. So the Pythagorean theorem, a squared plus b squared, a and b are always the two legs of the triangle. C is always the hypotenuse of the triangle, and the hypotenuse is always the longest side, and it is the side opposite the 90-degree angle. So make sure when you're using Pythagoras' theorem that it is a squared plus b squared equals c squared, which really means leg squared plus leg squared equals hypotenuse squared. So you want to make sure the hypotenuse is always on its own in that spot of C. So in example 1, they simply ask, solve for the missing side of the triangle, give exact simplified answers. Meaning in this section, exact simplified answers mean no decimals, so we write it as a simplified radical or a simplified radical expression. So if we look at A, we were given the length of A is 3, B is 8, and C is what we're trying to figure out. So we'll set it up as a squared plus b squared equals c squared. 3 squared plus 8 squared equals c squared. 9 plus 64 is 73. So c squared is 73, meaning c is the square root of 73. Now we want to look at the square root of 73 and see if we can simplify that using perfect squares. Square root of 73 is the square root of 9 times 3, which simplifies to 3 square roots of 7. In part B, we have a equals 6, b equals 7, and c is our question mark. So we set it up again, a squared plus b squared equals c squared, or 6 squared plus 7 squared equals c squared. That gives us 85 equals c squared, which is the square root of 85. So in this case, can the square root of 85 be simplified? No, it cannot. So our answer simply is c is the square root of 85. In parts C and D, we are solving, in this case, for one of our legs. So in part C, we have 4 squared plus b squared equals 11 squared. 16 plus b squared equals 121. So if we subtract 16 from each side, we get b squared equals 105. Square root each side, and b equals the square root of 105. Check if we can simplify that, which we cannot, so b is simply the square root of 105. In D, we're solving for a, so a squared plus 5 squared equals 9 squared. A squared plus 25 equals 81. Subtract the 25 from each side, and a squared is 56. Square root each side, and a equals the square root of 56. which we can simplify to the square root of 4 times the square root of 14, or 2 square roots of 14. In part E, we were given A is the square root of 2, B is the square root of 7. We're finding C. So the square root of 2 squared is 2, square root of 7 squared is 7. So 9 equals C squared, and the square root of 9 is 3. And then in part F, we have A equals 3/5. We're solving for B, and C equals 1. So our setup, 3/5 squared plus B squared equals 1 squared. 9/25 plus B squared equals 1 squared. So 1 minus 9/25 is 16 over 25. The square root of 16 over 25 gives us B is 4/5. In part D, or in part 2, example 2, determine whether the given lengths are sides of the right triangle. So what we're doing here is technically using what's known as the converse of the Pythagorean theorem, which you'll work with quite a bit more in geometry. But what that tells us is if a squared plus b squared equals c squared, then it is a right triangle. If a squared plus b squared does not equal c squared, then it is not a right triangle. So what we want to do is just simply check, does a squared plus b squared equal c squared? And we need to keep in mind that c is always the largest number. So in part A, 4 squared plus 4 squared, we're checking, does that equal 8 squared? 16 plus 16 is 32. 32 does not equal 64. So no, that is not a right triangle. In B, 9, 12, and 15, so 15 is C. So 9 squared plus 12 squared, checking if that equals 15 squared. 225 equals 225, so yes, it is a right triangle. Set it up in C and D, a squared plus b squared, check if it equals c squared. So in C, 64 plus 64 on the left, 8 square roots of 2 squared is 128, because that becomes 8 times 8 is 64, square root of 2 times square root of 2 is 2, so then 64 times 2, 128. 128 equals 128, so yes, it's a right triangle. And in D, we will set it up. Now, when you square it, I would leave it in fraction form. So 3/2 squared is 9/4, and 5/2 squared is 25/4. And then 9/4 plus 4. 4 is the same thing as 16 over 4. So 9 plus 16 gives us 25 over 4. So 25 over 4 on both sides. Yes, it is a right triangle. Then example 3, find the missing length, and this involves some variables. So we still set it up as a squared plus b squared equals c squared. So our two legs squared will equal our hypotenuse squared, meaning x plus 3 squared plus x squared equals 15 squared. So then we need to FOIL the x plus 3. So that would give us x squared plus 6x plus 9 plus our x squared equals 225. Combine like terms, and we have 2x squared plus 6x plus 9 equals 225. And to solve our quadratic, we need to get it equal to 0. So we'll subtract the 225 from each side, and we end up with 2x squared plus 6x minus 216 equals 0. Now we want to factor this trinomial. So the first thing we can do is divide everything by 2. And then we need to undo the foiling and break this down into our two binomials. So x squared plus 3x minus 108 gives us x minus 9 and x plus 12. And then we take each part and set it equal to 0. So we end up with x equals 9 or x equals negative 12. Now, because they're asking about a length in a triangle, we know length has to be positive. We could not have a side of a negative number, so our only answer to part A would be x equals 9. In B, our two legs are both x. Hypotenuse is 9 square root of 2. So our setup, x squared plus x squared equals 9 square root of 2 squared. Then 2x squared equals 162. Divide each side by 2. X squared equals 81. Square root each side, and x would be a positive or negative 9. But again, because we're talking about distance, x has to just be a positive 9. And then in part C, our setup would be x squared plus 7 square roots of 5 squared equals 2x, and both parts of that are squared. So then we end up with x squared plus 245 equals 4x squared. Subtract our x squared and end up with 3x squared equals 245. Divide by 3 and then square root each side, giving us x is approximately 9.04. And then example 4, a word problem here, says that we are traveling from Monroe to Harrisville. You can avoid the city traffic by staying on the roads shown in the diagram. If you travel straight through the city, how many miles will you save? So in this case, if we look at simply Harrisville and the length down to Monroe, that gives us a right triangle. So one option is to take the route here from Harrisville over and then down, which is 27 miles. Our other option would be to figure out the distance straight through the city, even though there's traffic. So we can use Pythagorean theorem, 12 squared plus 15 squared equals c squared. So 369 equals c squared. Square root each side, and we get c is approximately 19.21 miles. But to answer the question, they're asking how many miles would we save. So we have to take the original 27 miles and subtract our 19.21 to find out we save approximately 7.79 miles. And our last example for this lesson, example 5 states a football field is a rectangle that is 100 yards by 60 yards, not counting end zones. What is the length of the diagonal from one corner of the field to the opposite corner? So you can see I started with drawing the image and drew in one diagonal, and that creates our right triangles. So our right triangle has a leg of 60 yards and 100 yards. So 60 squared plus 100 squared equals c squared. So 13,600 equals c squared. Square root that. And c is approximately 116.62 yards.